The best engineering teams in the world commit to main every single day, sometimes multiple times a day, and they almost never break production. Here's the thing though, they're not better at writing bug-free code than you are. They're not smarter. They don't have better test suites necessarily. They have a different mental model of what deploying code actually means. For most developers, deploying and releasing are the same thing. You push code and users get it. Immediately, all of them. The best teams have decoupled those two things. They deploy constantly, but they control exactly who sees what and when. They can ship a half-finished feature to production dark, invisible to users, sit on it for 2 weeks, test it internally, gradually roll it out to 1% of users, then 5, then 25, then 100. And if anything goes wrong, they can turn the whole thing off in 30 seconds without a rollback. The mechanism that makes this possible is feature flags. And today, I want to break down exactly how they work, why they change your entire relationship with production deployments, and what you need to know to use them well. I'm Alex. This is Bot Thoughts by AmtocSoft. Let's go. A feature flag, also called a feature toggle or feature switch, is exactly what it sounds like. It's a conditional in your code that controls whether a feature is active. At its simplest, it's an if statement. If the flag is enabled, run this code. Otherwise, run that code or do nothing. That's the core idea. The sophistication comes from what controls that Boolean value and who can change it and how granularly you can target it. A basic feature flag is just a configuration value. True or false, stored in a config file or an environment variable. You flip it in your deployment config, you redeploy, and all users see the new behavior. That's useful, but it still couples deployment to release. To do better, you need dynamic feature flags, flags whose values are evaluated at runtime, without a deployment. Dynamic feature flags are typically stored in a database or fetched from a feature flag service. Your application requests the flag value at the point where you need it. The flag service evaluates the value based on rules, which user is requesting it, what percentage of traffic should see it, what time it is, what environment you're in. It returns a value. Your code branches accordingly. Now you can change a flag without deploying. You log into your flag management system, you flip a toggle, and within seconds your production behavior changes. No deployment, no rollback, no code change. That's the superpower. The most commonly used feature flag pattern is the percentage rollout. You have a new feature. You want to release it carefully. Instead of showing it to nobody or showing it to everybody, you configure the flag to evaluate as true for a percentage of users. Start at 1%. Monitor your error rates, your latency, your business metrics. Everything looks good. Bump it to 5, then 10, then 25, then 50, then 100. This is sometimes called a canary release because you're exposing the change to a small group first, like a canary in a coal mine, before rolling it out broadly. The key to this working well is consistency. Users should have a consistent experience. If the flag evaluates as true for a given user, it should stay true for that user across all their requests. This is called sticky bucketing. Typically, you hash the user's ID to determine their bucket, a number from 0 to 99, and you show the feature to all users whose bucket number falls within your target range. Same user, same bucket, same experience every time. What do you measure during a rollout? Error rates are obvious, but you also want to watch business metrics. Conversion rate, average session duration, revenue per user. Sometimes a feature is technically correct, but makes things worse for users, and you want to know that before you've shown it to everyone. This is where feature flags become more than just a deployment mechanism. They're an experimentation platform. The A/B testing that high-volume consumer products run at massive scale, that's feature flags with careful metric tracking on top. The kill switch is possibly the most important use case for feature flags in production systems. A kill switch is a flag that controls a feature or integration that could fail in a way that impacts availability. Third-party payment processor, external recommendation engine, new search algorithm, AI-generated content feature. When you wrap these integrations in kill switches, you gain the ability to instantly disable them if they start misbehaving. Not with a deployment, not with a hotfix. In seconds from a UI, I've seen this save teams multiple times. New AI feature starts generating inappropriate content. Kill switch, flip it off in 30 seconds, figure out the root cause without users being affected, fix it properly, re-enable. Third-party integration starts returning 500 errors and your error rate spikes. Kill switch. Your service falls back to its default behavior. Users experience degraded functionality, maybe, but not complete failure. You've bought yourself time to investigate. The mental model shift this creates is significant. When you have kill switches, your attitude toward new integrations and new features changes. You become more willing to ship things because you know that shipping doesn't mean you've committed to it working perfectly forever. You have an eject button. Production becomes less scary. Here's one of my favorite patterns in software engineering, the dark launch. A dark launch means you run new code in production for real users with real data, but in shadow mode. Users don't see any results from the new code. You're just running it to see if it behaves correctly in the real environment. Classic example, you're replacing a search algorithm. The new algorithm is faster and theoretically more relevant, but you've only tested it on synthetic data. In production, your users have bizarre edge cases, unusual queries, character sets you didn't anticipate, query patterns you couldn't model in a test environment. With a dark launch, you deploy both algorithms simultaneously. For every search request, you run the old algorithm, that's what the user sees, and you also run the new algorithm in the background. You compare the results. You log any discrepancies. You measure the performance difference. You do this for a week, silently, with zero user impact, before you even consider showing the new results to anyone. This is how you get confidence in new systems without betting your production on them. It's common in payment systems, shadow running a new payment processor alongside the old one. Common in recommendation systems. Common when migrating databases or storage backends. Feature flags are the mechanism. The new code path is behind a flag. You enable the flag for all users in shadow mode. The branching logic is always use old system for the actual response, but also run new system if flag is enabled and compare results. Dark launches dramatically reduce the risk of production changes. They're worth the engineering investment for any system where correctness really matters. Okay, I have to talk about the downside, because if I don't, I'm not being honest with you. Feature flags create technical debt. Specifically, they create something called stale flag debt. Every flag you add is a branch in your code. Every branch is complexity. When a flag is temporary, you're doing a rollout, you hit 100%, you're done, that flag should be removed. The temporary branch in your code, the old code path it was protecting, all of it should be deleted. In practice, this almost never happens as fast as it should. Teams accumulate flags. 100 flags, 500. I've talked to engineers at large companies with over 1,000 active feature flags, many of which were fully rolled out or fully killed but never cleaned up. This creates genuine problems. Code becomes harder to understand. Every feature has conditional logic around it. Testing becomes combinatorially expensive. You have to test every combination of flag states. The flags interact with each other in ways that are hard to reason about. Eventually, someone tries to understand a bug, and they spend an hour just figuring out which code path is actually executing. The discipline you need is flag lifecycle management. Flags should have owners. They should have planned expiry dates. When a rollout completes, there should be a task to clean up the flag. Some teams have automated linting that flags any feature flag older than a certain age as a build warning. Others have quarterly flag cleanup ceremonies. Self-discipline here is hard. The tooling helps. But fundamentally, flags are code, and code needs to be maintained. Last segment, should you build your own feature flag system or use a SaaS platform? Let's talk about what SaaS platforms give you. LaunchDarkly, Statsig, Split, Flagsmith, Unleash, these are the main players. You get a feature flag SDK for every language, a management UI, percentage rollouts, targeting rules, analytics, audit logs, and often an A/B testing and experimentation layer on top. You can be up and running in an afternoon. The SDKs are battle-tested. The infrastructure is someone else's problem. The downsides, cost at scale, and the fact that your flag evaluation depends on an external service. If the flag service goes down, your fallback behavior matters. Most SDKs cache flag values locally, so you degrade gracefully, but it's a dependency you have to think about. Self-hosted options like Unleash or Flagsmith give you full control. You run the service. You own the data. You're not paying per seat or per MAU. The infrastructure burden is yours, but for teams with strong DevOps, that's manageable. Rolling your own is viable for simple use cases. A flags table in your database, a simple API to evaluate flags, a basic management UI. Plenty of teams have done this and it works fine. The risk is that you end up reinventing features, sticky bucketing, SDK caching, targeting rules that the SaaS platforms have already solved. My take, if you're a team of fewer than 20 engineers and you're just starting out with feature flags, pick a SaaS platform. The time savings easily justify the cost. If you're at scale with specific security or compliance requirements, evaluate self-hosted options. And if you're already deep in infrastructure work and need tight integration with your platform, rolling your own is a reasonable choice. The teams that ship the fastest and break production the least have one thing in common: they've decoupled deployment from release. Feature flags are the mechanism. Kill switches, percentage rollouts, dark launches, these are the patterns that make it work. If you're not using feature flags today, here's your homework. Wrap the next feature you build behind a flag. Just one. Keep the old code path. Test the new one in staging with the flag on, production with it off. When you're ready, flip it. See how that feels. Once you experience the confidence that comes from having an eject button on every feature, you'll wonder how you ever shipped without them. Full blog post on feature flag patterns, with code examples in TypeScript and Python, is in the show notes. I'm Alex. This is Bot Thoughts by AmtocSoft. Subscribe for more on the tools and practices that define how the best teams build software. See you next time.